So like it was mentioned, my name is John Joe, and today I'll be talking a little bit about building maintainable modern Scala services. Can you all hear me just fine?
Yeah.
Okay, great. Yeah, so just to introduce myself a little bit, so I was born in Chicago, grew up there, and previously I've worked at Amazon for around 5 years as a backend developer. 7 years ago I came to Japan, and then for the past 4 years I've been working for Givery. Originally I started on the track test team, which is our coding exam platform. But for the past couple of years, I've been working on a different team as a engineering manager as well as a developer. Reading development currently for a skill growth and a talent management platform that we've been developing in conjunction with Toyota. Um, yeah, and so just for the agenda of this current presentation, I want to talk a little bit about why I started focusing on building, ideal microservices. And, next I'm going to cover about why I chose Scala as my language of choice. I'm going to talk about, what, in my opinion, makes a good microservice and, the actions that I took to implement these ideas. And then, I'll be wrapping things up with a few final thoughts. And just to, in the interest of time, I might not be able to cover every single aspect of microservice development. I know it's quite a complicated topic, but I'll try to focus in on a few points that I think are maybe a bit more interesting or different with the approach I took. Um, so the first part, talking about the new service opportunities. So originally, as I said, I worked on track test, which had a pretty mature backend, and I was tasked with developing a new central account service, which would serve multiple of our products: track test, track training, track job, which are all within our track ecosystem and serve as a way of connecting users between these platforms. And at this time, I kind of had the opportunity to re-envision our service setup. Um, so the question I kind of face with building a new service is, how much should I reinvent the wheel? It's a lot easier to build something fresh than to do a major refactoring, in my experience. But, there's every new technology introduced introduces new burden on developers within the organization. The initial development time is a lot longer, and, maybe what you end up going with works worse than what you know worse. So the situation I was facing with our legacy systems, so they're primarily developed using a Play framework on Scala 2.15, and some of the dependencies were blocking Scala 3 migration, so they were kind of stuck on Scala 2.13. Play framework itself isn't bad, but it did introduce some limitations due to how the ecosystem works. There were also many former developers of the product who all had different coding styles, and they contributed in different ways, but the code base itself ended up being very inconsistent as a result. Um, we had internal Scala pipelines, which were manually written and contained inaccuracies. API documentation was manually written, containing inaccuracies, and the internal TypeScript clients that were published were also manually written and contained inaccuracies. There was tight coupling between services, so one key service outage would bring down multiple services. And there were instances of backwards incompatible changes not being detected, which resulted in refining rollbacks or updates. And there were also inconsistent applications of functional programming principles, despite using the Scala language. None of these things are strictly enforced with Scala. And other things I won't go into. Um, but so the first question I had to face was, should I even stick with Scala in the first place? And I did consider some other programming languages. Scala does have some downsides, such as being quite complex for newcomers. It's also pretty slow to compile compared, it's like double the compilation speed of Java. Um, it's also kind of difficult to hire for because most engineers don't have Scala experience, and it's definitely a lot less popular than other languages. So a lot of the open source libraries aren't as actively maintained as some other programming languages. But I did decide to stick with Scala for the following reasons. So I believe that functional programming principles are actually very well suited to collaborative development. So the ideas of immutability, explicit side effects, and then having like modular and reusable components, these are all very relevant for, just working in an organization where you have multiple developers coming in, coming out, switching teams. And these type of things can enforce really good habits. And Scala is a language that's very well suited to functional programming principles because that was designed from the beginning with those in mind. Scala also makes up for its lack of popularity by utilizing the JVM. So even though Scala language itself doesn't receive as many frequent updates as like Java, we're able to leverage the benefits of Java, the performance upgrades that come out, as well as using Java libraries, which are still compatible with Java or with Scala. Additionally, having strong static types allows us to catch errors at compile time rather than runtime, which is very important for, quickly detecting things that are going wrong. And Scala also has very complex asynchronous systems that supports, which are, actively developed in Scala and don't quite have alternatives in other platforms. These are like Hako, if you're familiar with them, as well as Cat's Effect and Zeal. And it's actually pretty approachable as a language, for starting out, as long as you kind of have an appreciation for elegant code. The idea of using Scala is that you're not necessarily looking for the fastest solution to a problem, but the best long-term solution to a problem. And Scala 3 is still evolving and is, adding many desired features and has already fixed a lot of the issues that Scala 2 had. So I think there's a lot of benefits to Scala moving forward. And it's also very well enjoyed by a lot of the Givery engineers. So it's kind of part of our identity as Givery engineers. So didn't want to move away as well for that reason. So after making the decision to stick with Scala, I kind of focused in on a few points of what I believed defined a good microservice. And these were all kind of point where I felt were lacking in some of our other services. So for each of these points, I'm just going to kind of briefly discuss the idea behind it, and then talk about what I did specifically to implement these ideas within the new account service I was developing, and then I've taken forward for the new platform I'm developing as well. So first one being in Discoverability. So this one's pretty straightforward. Service contract should be clearly and accurately documented. Release history should be published and visible. And I think the key thing here to focus on is accurate documentation, because documentation can really only be accurate in my experience when it's automatically generated. Any situation where you're manually updating documentation is, there's always potential for errors. And so, the key thing I wanted to solve was how to sort of automatically generate this documentation. And the solution that I went with was the Tapir library in Scala. I'm not sure how many of you are familiar with it, but the idea behind it is separating endpoint definitions from server logic. And in the separation, essentially the endpoint definitions can then be used to automatically generate API documentation. And there's a guaranteed type safety between the server logic and those endpoint definitions. So the result is that you have automatically generated API documentation, which is guaranteed to be correct with your code because of that type safety. And this is really powerful. The first thing you might think of is just that it provides nice API documentation, which is great for working with front-end developers. But there's also a few more use cases which come out of this. And so, the next point I want to cover is flexibility. So, there's a few points here which are kind of well understood, like the idea of loose coupling versus tight coupling. So, like utilizing event-driven architecture where applicable, having one service outage, not, propagating to other services as well. Another key point, in my opinion, is publishing client libraries in all supported languages within whatever company context you're working in. So for the sake of Givery, we had, projects that were written in Scala, C#, TypeScript. And so, being able to support these clients as well was important. And then having BGAV versioning for frequent changes. So the things I utilized, so we're already on AWS, and I think outside of AWS, there's equivalent tools, but the service that I utilized quite a lot in this new service development was AWS EventBridge. It's actually a very powerful tool that is relatively recent, and what it provides is asynchronous processing, built-in retries. It's also really testable because unlike a SNS SQS solution where you're working with a polling system, it can directly invoke API endpoints. And what this means is that everything is really easily testable, the same way you would test any of your API endpoints. And it also allows you to have very good scaling, as we'll see. And then the next thing is, as I mentioned about Tapir before, with this API documentation, as long as it's guaranteed to be accurate with your service, what you can do is there's a tool I use called OpenAPI Generator, and it turns that automatically generated OpenAPI specification into clients in other programming languages. And this allows me to have automatic release flows in Scala, C Sharp, TypeScript, etc., without having to even like write a single line in those programming languages. And it scales really well for providing microservice for the entire company without limiting those other services to your specific programming language. So the next point I want to cover is scalability and fault tolerance. So, this is also, another kind of standard idea that prioritizing high performance standards and, being able to scale to demand in the future, as well as, meet future edge cases, and having systems in place for, being able to handle specific errors. So the system that I added to this new service I was developing was Cat's Effect. And I think Zio would have been probably equally as good, but I used Cat's Effect based on the previous experience of other engineers on the project. And the idea, it has several ideas. One is utilizing fibers, which is splitting up the thread pool into inner threads called fibers, which allows you to handle a lot of simultaneous processes and provides very good vertical scaling. So, increasing the CPU of your server allows you to handle a ton more requests. It also has very explicit and comprehensive asynchronous process management, and it provides something called referential transparency. This may not be a term you're familiar with, but the idea is that the output of your function and the content of your function are replaceable. So every Cat's Effect function outputs a IO of some result type, and this IO of the result type is the same as the function in essence. So careless refactoring is one of the things that it's kind of famous for. You can move around your code very easily, but you can also do things like adding in retries on that IO result object without even having to retry the function or anything like that. And the other thing is, what I mentioned Event Bridge before, that utilizing Event Bridge to invoke my own service. So for panning out requests, while getting all of those same benefits and easy testability. And that allows for a certain level of horizontal scaling. So for example, like batch invite processing, being able to handle thousands of invites all at one time. Event Bridge is a great solution for all. So the next point I wanted to cover is a bit about sustainability. And there's a lot of things that could kind of go into this topic. But main things I want to focus on is the internal consistency of the code base. So things like code formatting, style guides, and like having logical separation of responsibilities, as well as having clear development standards. So the idea is that a new engineer who comes into the product should still be able to easily figure out how to develop like a new API in your service. And in my opinion, services should be flexible, but code bases should be opinionated. There shouldn't be a big question of or a ton of freedom with how to implement things so that everyone's implementing APIs and all different methods within your same code base, because that just leads to chaos and really difficult time doing refactorings. And then finally, just having automation work equipable for all types of manual processes like testing, release publishing, deployment, etc. So one solution I'm going to hone in at here is so I ended up going with the use case software design pattern. So the idea of the use case software design pattern is that business logic is sort of encapsulated into like meaningful use case classes. And I sort of expanded on this idea, developing a use case type class. So kind of like an interface, but a little bit more powerful. This is a concept from both like Scala and Haskell. And so you see how there's a trait use case, which has a request type, a response type, and an error type. And this sort of allows me to ensure a consistent application of business logic across the program. Within these use cases, I also have a required specification of the DB isolation level. So read-only use cases, read-write use cases, or just non-DB interacting use cases, which helps to ensure that, a list API is only ever going to list. It will never, modify the database or anything like that. And then, with these specific request, response, and error types, it allows me to have a built-in retry functionality, utilizing that same referential transparency. So for actions that I really do not want to fail no matter what, such as like publishing email or sending events in EventBridge, I can have built-in retries for these actions defined at this common level. So that's all very powerful. And the additional thing is, previously I mentioned that Scala has long compilation times, and that's true because it's doing so much of compilation so in order to check the safety of the program. But one thing that can drastically speed that up is incremental compilation, so that only the parts that change every time you're developing need to be compiled. And for that to work better, having a larger separation of modules really benefits that process. So, these are kind of the different modules that I have in my application. And the idea is also then, for the sake of publishing, I only need to publish the parts of my code base which are required for other services without having to publish any like the service logic or anything like that. So all these things combined kind of makes sure that the code base itself is very clear with how to develop, and there's not a lot of flexibility for engineers to develop in a different way, which helps ensure that even someone coming into the code base fresh has a good idea of how to develop there. Yeah, and another thing that we do is also publishing TypeScript models for the front end to use, so that the front end is able to depend on those same open API specifications as the back end, which helps to ensure that the front end is always doesn't have to think about the arguments that it's passing and making sure names match up or anything like that. That's all just given by the published front end. And then also having a backwards compatibility test pipeline where essentially we publish versions of our test using different versions of our client in order to test all of those previous client versions that are supported against our server updates, which allows us to immediately catch any backwards and compatible changes at the beginning development phase. So final point, I won't touch about this one too much in the interest of times, but it's about having observability, having clear performance data, having informative errors, and having meaningful audit logging. So I won't cover all these parts. The main part I want to cover is just that by having this error type for each use case, and then utilizing something called partial functions, where I only actually match on certain cases that I want to convert into client errors. It allows me to have very informative errors for every possible case without having to worry about actually handling all of these errors. Everything that's not handled turns into a 500 exception. So I still get all the type safety of the error handling, but it allows me to have very informative errors, and it encourages all of the other developers to write informative errors because they don't have to deal with the pains of handling things that probably won't happen, but if they do happen, we want to know exactly what happened. So that's all I'm going to cover with that part. But so yeah, just getting into a few final thoughts. And so the first one is kind of building systems to ensure best practices. I haven't fully figured this one out. I have a lot of things with codebase, and some things are specified in the README about how the development process should be. But I want to try to work on developing more tools to kind of help ensure that those best practices are kept to. So I'm looking into Scala metaprogramming now. Things like developing macros for this purpose, as well as utilizing like GitHub actions in certain situations to make sure that the standard practices of code base kept to. Another point that I want to talk about just briefly is kind of the future with AI. As we all know, AI is coming into our development process, whether we like it or not. And I think the role of the developer is kind of going to change a little bit. It's not so much about solving hard problems, just being able to solve a hard problem. But I think what we as engineers can really provide is a basis for this AI to be able to contribute to our code bases in a way that is clear, it's consistent, it's readable, and we instantly know if the AI is breaking anything. And I think that, Scala itself, or just these functional programming principles, are very well situated to this future we're looking at with AI development. And yeah, but that's, we'll have to see if this remains true. Maybe it'll instead just be better to have like fast programming languages, which just break things and then just use the AI to fix everything that's broken. But I do think there's a lot of value in establishing all of these standards at the beginning and then letting AI then contribute based off all of these like clear development guidelines. So that's about all I had to cover. But I believe we have a bit of time for questions.
Yeah. Does anyone have any questions? Okay.
Yeah.
You mentioned that the compile time for Scala was long. I'm not very familiar with Scala. Could you help me understand what long means and what your kind of compile events are? Like, are you compiling the entire backend? Are you compiling just a service? Or like if you're running a test or a suite of tests?
Yeah, so doing like a fresh compile from the beginning, at the size of our like larger code bases, I would say it probably takes, it's scaled like a few minutes. Um, and this is definitely like slower than say like Rust. Like Rust compiles like extremely fast, right? What Scala is doing at compile time, one thing that's doing a lot is using all of these macros and expanding these sort of like um, boilerplate parts of the code into the other parts. Scala is kind of built on a lot of these like auto-generated code things, and then it's sort of ensuring all of the types match across the entire program. There's this feature of Scala called pattern matching, where it kind of goes through, instead of using if-else statements, you explicitly write out like each case that you want to handle, and it's a lot more powerful than say Java's like case handling. And one feature it offers is it can tell you if any cases are not being covered by your pattern matching. But in order to figure all these things out, extra compilation time is needed. But this compilation has a purpose. It's not just like slow for the sake of being slow.
Thank you.
Mhm. Yeah.
Oh, okay. Really quick, like, so when you talk about Scala, I knew Scala much better. Most of the functional terms are similar to what you see in Haskell. Yeah, exactly. Yes, but more. So you talk a lot at the beginning about kind of decisions you make when you start a project, both libraries, use things like that. Which I agree is, well, decisions are really important. What is your discovery process like? This is something I've had a lot of difficulty with as from signing projects in Python, because the ecosystem is so large and it's often not well documented. And I'm curious how that is with Scala, what process you go through.
Yeah, I mean, I will definitely say, for building this new like account service at the very beginning, there was a lot of this, trial and error and just figuring out the best way of doing things. And that was kind of like what I mentioned about how, when you're doing this new service thing, there is this trade-off of this extra time if you're like trying to reinvent the wheel. Luckily, at that time, there was kind of the required deadline for development and the starting point for development. There was a bit of extra bandwidth in there for me to kind of play around with things, and it gave me a chance to try out a few different. So I tried out a few different database libraries. I tried out Doobie, and then moving over to Skunk eventually. I tried out these different patterns for publishing things. I ran into some potential errors and like pitfalls with my auto-generated API adaptation, but I think like at some point this time investment needs to be done, and if it's done very well, you kind of have then a new template to work off of for all these like future projects. And I don't think it's something that should be done every time you build a new service, just because that would just take so long. But every once in a while, every several years, I think it's important for a company to just kind of reevaluate like completely from scratch, what should we be doing for development, what are the best tools for our what we're trying to do, and then kind of building this system of like what are the new technologies we should be working with.
Yeah, sir.
You mentioned avoiding error handling ambiguity. Does that mean that you're implementing a specific error for each function?
Yeah, so each use case mentioned there has its own distinct error class. And not only that, we also, one thing that Scala 3 provides is something called a union type. So you can create a type which is the combination of multiple types. So for example, if I'm calling a certain service which has its own error class, then the output of that error can be the union of that service's error class and then my own use case's error class. Which lets me then, specifically specify all of the cases that I want to handle among those errors, and then everything else, yeah, maps into 500 exceptions. But you get a lot more type safety than just like a generic exception class.
Thank you.
Uh, my question is about how you handle breaking changes. Like you have a pipeline to detect it as a breaking change.
Yeah.
And what does it work after? Like, do you have multiple versions running at the same time?
Yeah, so what I do is I have a compiled version of my test class. This test class is a little bit more simple than like my thorough test, because I mainly want to focus on happy cases. I don't really care that much about all the possible edge cases for the sake of a backwards compatible pipeline. But what I want to make sure is that every single client can like call and respond and handle all the JSON inputs and everything without any failures. So what I do is I have whenever I'm releasing a new version of the service, I have a process for publishing a new version of the test class. And then for each supported version, so like essentially, because we have like multiple dependencies, which we're calling our service, and all of these, previous versions are considered our supported versions. So they all need to work off our current server. And once I can get all those other services moved away from that version, then I can delete those tests from the pipeline and just focus on wherever the current versions are. So that's kind of the point where I can like deprecate old endpoints officially. Yeah, for like the short term, I'm just, developing like new versions of our API endpoints if there's a breaking change and pointing the client to that new version instead of the old version.
And how do you track that everyone has been migrated properly?
Yeah, so that part's a little bit difficult, and that's one of the, things I'm trying to work on having a better system for, because it kind of relies on, like code reviewing and catching it myself and just having the understanding that this should be covering all these things. Yeah, there's not a lot of break systems to ensure that best practice is adhered to.
Thank you.
Yeah.
Oh, you mentioned like the existing systems before your tile service. You had issues with them, like they coming migrated to solid and so. Did you like put the changes you made for tile services back to the other services as well?
Yeah, so and this was a little bit tricky to figure out. And essentially what I have to do is I develop my new service in Scala free, but I still needed to make it cross-compile into Scala 2 so that my Scala 2 services could depend on it. And there were some features I was unable to use then. Like opaque types is a Scala 3 feature, but it's not supported in Scala 2. For some parts of the code, what I have is like essentially a Scala 2 version and a Scala 3 version of the same code. So my server is running the Scala 3 version, but when I publish it, I use the Scala 2 version. And I use that in a few key areas where there's just a Scala 3 feature that I really want to use for my service. But then I, can't use that on it in the publishing. And actually, this is another area where having this module separation is really important, because I only need to support Scala 2 for those modules that are being published. So the things I publish are the core module, the endpoint definition, and then the client. But the services, the application, and the use cases, all those can just use pure Scala 3 features without any worry about that cross-compilation.
Okay, last one. Okay, I'll try and make it quick. So you mentioned earlier that you use Tapir to basically generate API flights that downstream services in other languages can use. Like, if you've come across any challenges doing that, that sounds like a bit of a logistical nightmare. You have to publish the artifact in TokyoDev and then has to plug the version.
Yeah, so I've set up a lot of automated like CI flows. So essentially all I have to do is just update the published endpoint version. And I have a separate versioning system for the like service client and then the front end SDK. And I also have a separate workflow which sort of automatically detects if there's any changes to the endpoint module. And then it puts a warning on the PR at that point that, hey, you need to update the front end SDK version as well. But then after changing that, on release, it will publish the front end SDK. It will attach the API documentation at that time, and then it will put a message in Slack to let the front end engineer know, like, hey, this is the new version you should be depending on. So I think that, we had to do a bit of trial and error for that best practice, but it's worked out pretty well for us so far. So thank you. Well, yeah, Alan, that's time for all the questions.
Okay, yeah. Thank you very much, John Bill.